Hi, Mr. Slater. This is Tenley. I wanted to talk to you about ionic bonding, metallic bonding, and covalent bonding. First, I'm going to start off with the basics, which is the periodic table of elements, a key thing to know in chemistry. So everything to the right of the staircase is a nonmetal, while everything to the left of the staircase is a metal. And this is an extremely important when it comes to ionic bonding, because with ionic bonding, metals lose electrons when they want to bond with each other. And so this makes atoms into ions. An example of this is lithium. Lithium, in this case, is on the left of the staircase, so it is a metal, but we want it to become an ion. Okay? So basically, we need it to lose one electron. But elements can gain or lose electrons. For example, chlorine, which I'm going to show an example below, actually gains an electron, and this is because there's one more proton than the electron. But one thing we need to remember is that the charge of an atom is always zero. But with an ion, it can be different, because an ion you have a different charge, which is something to be aware of. Now, and one last thing, everything on the table on the left of the staircase is a metal except for hydrogen. Now on to metallic bonding. Okay, metallic bonding. So you may be wondering, what is metallic bonding? Well, it's actually in the name. Metallic bonding deals with metals, which is pretty important, because when there's a strong melting points and boiling points that occur between atoms, causing them to bond, then it is a metallic bond. So we have three different types of metallic bonding elements. We have magnesium, which is extremely unique, which has stronger bonds and a higher melting point. We have molten metals, which is a metallic bond, which is when metallic bonding is still present, but its ordered structure has been broken down. And we have transition metals, which have strong melting and boiling points. Now, when metallic bonding occurs, the electrons become delocalized. So what does delocalized mean? It means when electrons are moving freely within molecular orbits, causing electrons to be detached from its parent atom. So that means when an element is at a high melting point and a boiling point, then the atoms will loosen up and become delocalized. Now finally, covalent bonding. So covalent bonding is the simple definition, which I have here for you to read, is a bond between atoms that involved sharing electrons, which only occurs between non-metals. So this is important because this only happens between non-metals. Okay? So we have hydrogen and oxygen. Oxygen is a non-metal, while hydrogen is it's not even classified. So this definitely works for covalent bonding. So as you can see, I love hydrogen. I think it's pretty adorable. It looks like a Mickey Mouse. Mickey Mouse when it's all together. So we have two hydrogens and we have one oxygen, which makes H2O. We have this diagram, which is really nice, and we have this one, this one's a little bit more developed. You can see basically hydrogen, carbon, and water, and these are all in something called a Lewis dot diagram, which shows the number of electrons on the valence shell. Now we need to know if it is polar or not. So we see that we found out that hydrogen has two pluses and then the oxygen has a negative. So what does that mean? Well, that's one step closer to finding out if it is polar or nonpolar. So we know that by looking at a table that displays the electronegativity of each molecule, we know that of each element, we know that oxygen has an electronegativity rate of 3.44, and hydrogen has the electronegativity of 2.20. So if you subtract those, you get 1.24, which means H2O is in fact polar, because it's more than It's more than 0.99. So I hope you enjoyed my quick presentation. I know you have a lot of these to grade, so I wanted to keep mine nice and short for you. But I hope you had a great Martin Luther King, and I can't wait to see you in class tomorrow. Thank you.